Welcome to my video. In this video I will do a review for exam number 2 for 1030-1040 at Salt Lake Community College. The test I have here we gave during the spring of 2018. Wait a minute, hang on a second, I'm going to pause you, I'll be right back. Okay, I'm back. Did you miss me? I just went and checked to make sure that I didn't give this exam as the practice exam. I just want to give you two different exams so that you have two different things to study with for your exam. So I will go through this one. This test had looks like 9 problems, and hopefully I can do it. Okay, so we're just going to start going through one by one here. Problem 1 worth 10 points. Acceleration A, a force F, and mass M are related using the following equation. Force equals mass times acceleration. A constant force of 100 newtons is applied to 5 different masses, here being the masses given. Create a table with column headers of force, mass, and acceleration, and display the values under the headers, 5 points. Then separately print the values of acceleration with decimal point of accuracy, 5 points. Do not use the table function. Okay, so we're going to make a table. First off, we need to define our known things here. So we have a force is equal to 100.0 newtons. Suppress that output, come over here and do our units. Units are not required, but highly recommended. Our mass is going to be 2 point zip zip, 4 point zip zip, 6 point zip zip, 8 point zip zip, and 10 point zip zip. 20 zips. Do a semicolon, and this is in kilograms. Line up our units so that it looks pretty. Okay, so now we'll create a table of force masses, then separate from the value of acceleration. Okay, so acceleration then is going to be force divided by mass. So our acceleration is equal to the force divided by mass. However, before you guys scream at me saying, hey, you can't do that, because we are dividing by a vector, m as a vector has more than one value, we need to use the dot element, or the element operator. That way it'll do it element by element. Okay, so there's our values that we want to put into our output, into our table. So we're going to create a table vector variable, and yes, I know I just overwrit the variable or the function table to make it a variable, which is fine because I don't like using the table function myself. I like having control over my output. So we're going to make our table vector variable here a matrix. Hopefully that is going to be 3 rows with however many columns, 1, 2, 3, 4, 5 columns. We'll suppress that output. Okay, so now let's create our table. So we're going to start with our display function, and we're going to put our force here. Oh, and that's going to be a problem. You guys, you didn't see that. Mass element. Sorry, we got a problem with the table that I just created, so I need to go fix it in some way. The problem here is that the force is only a scalar value. It only has one value, so I'm trying to put 1 in with these 5 here. A few ways to do that. I could do mesh grid to make them the same. I could turn this into a vector by multiplying it by a vector of 1 by 5s. However, let's do that. Let's to make this so that it has 5 elements in it, we're going to multiply it by a vector of 1s. So now it'll all have the same value of force, and it'll be actually let's make it so that it's dynamic to the input. Let's say we have a different number of masses. So now it'll do however many elements in mass it'll create for the force, and then no matter what, if I came in and changed this, added 2 masses, it would be the same. If I had that as 5, I could only use it as for 5 elements. Okay, so now let's do our fprintf to do this. So we do our single quotation mark. Force is going to have a set number of characters of 5 because there are 5 characters here. There's 3 of them with a 1, 0, 0, 4 would be the decimal point, and 5 would be that other 0, and it did say with 1 place decimal on the acceleration. So we want percent 5 characters and 1 decimal to the right of the decimal place, and then we'll do a little step over to get our masses. And if we print out the mass as shown, our largest number here also has 5 characters, 2 on the left, the decimal, and 2 on the right. So let's do a percent 5, only this time we have 2 on the right side of the decimal point. And then it wants our acceleration with 1 point of accuracy, and that would be because the most least accurate is going to be the acceleration. So when you're getting into sig figs, that's where that would be. So let's do a percent, and let's start with 5.1 and see where it goes from there. We lost our 5.1, and we'll do that on a floating point. Come onto that side, come over here and give it a table, and that should present a nice little table for us. Oh no, you forgot to do a new line at the end there to make it. There you go. And we can see we have some spacing issues. We've got too many spaces here, so we'll back that up, make those uniform, and then maybe 1 or 2 on the mass to line that, or maybe 1 more. Get the masses lined up, and then the acceleration falls in pretty good. So there we go. Is all that necessary for full credit? Not necessarily. If you've done everything that to present the table is fine. You would have to use the display function and also fprintf, because it says do not use the table function, and to use the fprintf for the data table. So there's problem number 1. Problem number 2. Here is I'm going to do a section break here. Oops, tip a section break. I guess we need to have that on the top, which is fine. Okay, so consider the nominal distribution function as its associated constants. Okay, so there's an equation up with some, create an anonymous function for f of x. So we're going to cheat here because the odds of me typing all that in there correctly to get everything in there. We're just going to call this f, and then to make it an anonymous function, we're going to have an @ sign with an x, and then we'll come and make sure everything is kosher here. So we've got a 1 divided by the square root of 2 times pi times that times minus mu divided by 2 sigma. Okay, that looks right. So let's calculate in our sigma, or define our sigma. So sigma is equal to 1. And mu is equal, I'm sorry, it's been a long weekend, is equal to 0, 0.0.0. And let's just for grins and giggles put these up here before our definition, just to be in a habit. Okay, so there is that. So part B is to do a create a plot using fplot where the range is from -2 to 2. Provide the title and axes names. So we're going to do an fplot, and we're going to send it f und we're going to give it a range of -2 and 2, and close with a square bracket, and it's already got the closing parentheses in there. Let's give it an X label of I don't know, let's be unique here. Let's call it X. Wow, how fitting that is. Y label, let's call it something odd, like maybe f of x. Too many. Oh, okay, cool. And then a title. I don't know. This is problem number 2. Okay, und there's our plot. Okay, so and then part C is to use G input to locate the maximum Y value of the function and the corresponding X value. So we're going to give a note to the user to tell them what we're doing. Display, pick the maximum point. And then we're going to say we want to know what those coordinates are, so we're going to assign them to 2 different variables, and G input, and we want to do just 1 point and then have it stop. This, by doing that, the user doesn't have to hit enter. And then let's display our results. We'll say fprint, and you could do this with a display also. Just change it from a num to a string. I like the fprint f because it gives me more control. The maximum point, I'm not going to say is selected because it doesn't. It's going to determine where you put your cursor. So, and let's 3.1 f, and then we want to give that a value of b, because that's going to be the maximum y value. And that's what the AB does. A is the X and B is the Y coordinates of your spot that you picked. And then we'll do an fprint f of, and in here we're going to say when X is equal to, and then we're going to do another percent, and let's do 3.1 also here, just in case there is some. Let's do a return up here too. I always forget the returns until I run it. And then this one here is going to be A, because A is the X coordinate. Okay, cross our fingers and see that everything runs here. Well, there we go. We got the function. Got okay. I didn't get a plot. Why didn't I get a plot? There's our point. There you okay. I got everything but the plot. Why didn't I get a plot? Okay, so it took me a second, but I found out why we had those errors in here, and apologies. Again, it comes back to stupidity on the operator's part. I have sigma in my equation, and I had simga. I had my M and G, a little bit of dyslexia. change those around to where they're supposed to be, and look at lo and behold, everything works. Now I'm picking, I realize that the high point is up here, but I want to make sure that my G input is working, so I'm going to pick a point a little bit off of height so I can see if I'm getting different values. See, I get different values for A and B, and then it rounded to, because there's only one place past the decimal. Okay, so I only get 13 points for this because I had an error in my variables. Okay, problem 3, 10 points. Commute times for 5 peoples for 3 days below. Commute times are given below. Use the max and min functions, determine and report which person experienced the longest commute using a complete sentence. Ooh, I don't deal in complete sentences. Yes, you do. Okay, so I'll start. So, okay, so looking over this data here, we're given 4 vectors, a personal number, the days Monday, Tuesday, and Wednesday. It wants us to find which one of these numbers has the greatest commute, and which person and the longer, using complete sentence. Okay. So I'm gonna create a matrix of all the data points, and let's see. Those are. I'm gonna change and make my columns rows, or my rows columns. Why, I don't know. I just for each. Why? Okay, let's leave it and see what happens here. But we're going to put each one on a separate row. Oops, Tuesday and Wednesday. So there gives me my matrix. And then we want to determine the max function. So the max, come on, you can spell max commute is going to be, find which value in the data, no, I don't. I want to find nothing. I tell you, I am so tired. I want to find the maximum value in my data file. So I'm going to go data, and I'm going to turn that vector into a single column vector, so I can just find the maximum value inside of there. And now we're going to find the row and column. Going to find where in data is equal to max commute. And so the row is going to tell me which day, and the column is going to be which person. So let's, and it says to use the fprintf functions to determine which person had the longest commute. Use complete sentence. Okay, I'm not an English major, so I don't know what a complete sentence is. I just have run-on sentences that go on forever and ever and ever and never stop because I never shut up. Okay, so I'm just going to put in here the maximum commute was, and then we'll print off what the maximum compute was. There's no decimals and only 2 points. And on okay, we haven't learned how to do the characters yet, so we'll just buy um, um, uh, by commuter number, and then we're going to have a display, and this is only a single digit, 1.0f, and return, and we ended that stuff, and now, so the maximum commute is going to be max commute, and and then the person is going to be, and this is where one of those places where, yeah, this is going to return the column, which is going to coincide with the number up here, but technically, to be correct, we want to have person number, because those numbers may not be in sequential order, and by column. And so you either have to manipulate the output or actually go back to the original vector and pull out the right. And now if we look at this, we can see here that the maximum value is right here at 62, and it's going to be by commuter number 2 on Wednesday, but we're not reporting which day. We just want to see that it is 62 by number 2. Cool. Good output. Okay, problem number 4. Okay, put another break here. I'm putting those breaks in so that I can just run each problem individually. If I didn't, every time I run it, it would run each of the problems beforehand, and that's kind of a nuisance. Okay, a placement exam directs which math class a student needs to take. If X represents their score, then X less than 70, they must take remedial algebra. That would be me. 0 to 90 must take college algebra. 90 would be calculus. Write code which prompts the user to enter the score and returns a message telling the user what math class they are to take. Okay, so first off, we need to have an input from the user. So we're going to do an input. Be polite, please enter your math score. Okay, oh, we don't need that. This isn't an fprintf, but we're going to put a space there so that it'll give us a space between our outputs. Okay, so now it's going to enter score. So now we're going to do some nested if statements. If score, and we're going to spell it correctly maybe, if score is less than 70, then display no capitals. You must take remedial algebra. Okay. Delete. Then we'll do no, get back up there where you belong. That's the thing I have issues with the live script editor. Else if, no, it's else if, come on, get back up there, is score is less than 90. Okay, so we don't need to put in the greater than or equal to 70 because it's already taken here. If it's less than 70, it'll go into here and then end. Then it will come in here, and if it's less than 90, so that means between 70 and 90, it will come in here and say display, and if you spell it right and put the parentheses in the right spot, you get through the test a lot quicker. Um, you must take college algebra. And then we'll just do a final else because everything else will be greater than 90. Display, you must take calculus. There we go. And then we'll finish off with an and we'll run this and we'll test it with different scores. So it wants to enter our score, so we'll go in a little less than 70, see what it gives us. So it tells us we have to take remedial algebra, and just so we have uniform. So now what happens if we put 70? It tells we have to take college algebra, which matches this here. See, it says 70 to 90. So let's run it again. Do 89 should still get college algebra. And 90. But yeah, less than or equal to 9, or greater than or equal to 90 of the calculus. So we verified that that works. Okay, problem number 5. Section break. Rocking. Okay, calculation of the value of pi. Yeah, that guy's some series was developed in the 15th century as a way to calculate the value of pi. Pi equals 3 plus 4 times 3 times 2. Okay, minus. Okay, yeah. So the hardest part on this one is figuring out how to model this mathematically in a loop. And I tell you personally, I think anybody that did that right should have gotten 100% on the exam, because you got alternating signs, right? So that's got to be raised to a power to get alternating plus or minus signs, changing numbers. So this is where taking out a piece of paper. Ooh, and I need to contact. I'm going to write a note right now. Contact ITC. Scratch paper is okay. It's okay if you take scratch paper to my exam. They will collect it at the end of it and shred it. But it's useful to have. So okay, so for our first digit we have 3. And we can set that up fairly easy. And then the second digit is 4 divided by 2, 3, 4. And then the next one is 4 divided by 4, 5, 6. And then the next one is 4 divided by 6, 7, and 8. Okay, so now let's look at this. So that's all 4 divided by some series that's changing each time through the loop. So we're going to have a -1. Okay, so the first time through the loop, our loop individual is going to be 1. So going through the loop, we want our negative sign, plus or minus, to change, add and subtract, to be a positive. So if we have our index variable plus 1, and if we raise number -1 to that, that'll make it positive, so it'll give us our plus for the first one. The second time through it'll be 2, will be negative, so that'll give us our alternating plus or minus sign through the series. So that takes care of that. And then we have 4 is a constant in each element of the series, so we can add a 4 in here. So we're going to multiply this by 4, and I'm just writing this down on a piece of paper so that obviously you can't see my paper. So now the first time through here, this is going to be if my index variable is 1, so that's going to be 1 plus 1 times 1 plus 2, or index plus 1 times index plus 2 plus index times index plus 3. but then the next time through is 2, so we have the index plus 2 plus times the index plus 3. Okay, so this isn't turning out to be a nice easy thing that we can do for the index. Okay, so let's go back and look at it again in a different way. Okay, that doesn't work. You see me scratch that out. Okay, so now let's look at multiplying. So the first time through the loop, if index is 1, so if we multiply the first one by 2, so that'd be 2 times our index times, and then if we're 2 times our index plus 1 would give us 3. 2 times 1 is 3, and then 2 times our index plus 2 would give us 4. Now what does that do for the next one time through? Next time through, if b is 2, 2 times 2 is 2, or is 4, so that works. 2 times 2 is 4 plus 1 is 5, that works. 2 times 2 times 2 is 4 plus 2 is 6, so that works for the second time. Let's go one more for 3. 3 times index 3 times 2 is 6, and then 1 plus that would be 7, and 2 plus 7 is 8. So there's the mathematical equation we need for our loop. Okay, so obviously you can't see what I've written on my paper, but I will transpose that over to the computer for you now. So first off, we need to have a variable that we're going to add up every time through the loop. I'm just going to call it my pi, and we're going to set it equal to 3 to begin with. Why are you setting it equal to 3? That don't make any sense. I'm going to set it equal to 3, and I will tell you why. Because right here, the very first element in here says it's 3. And rather than messing around with my equation trying to get something that'll give me 3 and then all this, it's so much easier to just say to initialize that at equal to 3. So now we're going to do a for loop, and then and also want value continue calculations until the absolute value of the difference between the value of pi stored in MATLAB and the approximation is less than 0.001. So we're going to have a break in here. Okay, so we're going to make a for loop go for a lot longer than we expect it to. So I'm going to put in, well, let's be reasonable here. We're going to put in 10,000 loops just in case. Okay, I know it shouldn't take that many. If I program it right, it should not take that many. We should not have an endless loop. So we're going to have my pi. I want some cherry. Is going to equal to my pi plus the equation that I've developed and have written down here on my piece of paper. So we're going to put all that into parentheses. So begin with, we're going to give our alternating sign of -1 raised to we got to have some kind of index variable here. Let's use I. Holly doesn't like using I because it's part of the IJK for imaginary numbers, but I've just been so ingrained for using IJK for my loops. So this is going to be I plus 1. This will give me an alternating plus or minus every time through the loop. So first time through, I is equal to 1, give me an even number, which makes it positive, which the first one here is positive, so that works. Now we need to multiply this by 4, because 4 is a constant through each time. See, we have 4, 4, 4, 4, 4, 4, 4, 4, and 4 is divided by what I calculated out is going to be 2 times I. That'll give me 2 the first time through because I equals 1, and then that's going to be multiplied by 2 times I plus 1, and then that's going to be multiplied by 2 times I plus 2. And I hope I got all my parentheses correct here. Where'd that one go? That one's Okay, that one's on that term, that's on the denominator, and that one's in there. Okay, so that I hope is correct. um, actually, I think I got a problem here. I think because I want all of this here multiplied by 4 and then that divided by that. Okay, and I'm going to suppress this output because we don't want to see it in the screen. Now we're going to do our check here. If the absolute value of pi minus my pi is less than or equal to, and our value here is 0.001. Okay, then I do that every time. Then I'm going to break. Stop the cycle. And there's an end there, and an end there, and then let's display to the screen fprintf. So my approximation, hopefully I spelled that right. Again, I'm not an English person. Is, and then let's go a whole bunch of digits here and use the right symbol. Let's give you no, let's 1 for the 3 and then the decimal point and then 5 digits. F. And then I'll report how many iterations, percent. Let's see, I got a whole bunch of iterations there, so let's just start off with 3. Don't want any decimal points on that. 3.0 F. Iterations. Okay. And then I'm going to get in the habit of start doing that. Okay, and then we're going to return my pi. That'll give you my calculation, and I will tell us on which iteration it stopped at. Is it going to work? Let's see. Stopped after 1 iteration. I think you can go further than that. Let's put that over there where it belongs. There we go. Now we got up to 6 iterations. So 3.14159. So that's within 3.14159. So that's within the 0.001. Okay. And if you wanted more accuracy on that, you could add a 0 here and run it again. Get a whole bunch of decimal points here, and let's change this to 17. Oh, it's not going to give you that many. Oh, because we got to get this here. Let's go 12. Oh, 15. Okay, 15. There you go. There's iterations. So anyway, you can play with it. Okay, problem number 6. Again, I don't know why we didn't put section breaks in this. I do remember now that it was a pain grading. I had to go put section breaks in everybody's assignment. Problem number 6 is another less effective way to estimate pi is Gregory Libs, that guy, his series, 4/3 minus 4, 5, 7, 9. Use a while loop to approximate pi using this technique. Continue this calculation with the absolute value of the difference between pi and the store less than 1. Repeat. Okay, so we're going to do the same thing, only this time we're going to do it in a while loop. So again, here we need to do our calculation. Let's start up again. My pi. This time we're going to start at 0 because the first number we can calculate. We need to establish a variable because we're going to use it on both sides of an equal sign inside. This time we're going to do a while the absolute value of pi minus my pi, and this time I'm going to put the parentheses on, is greater than 0.001. Then it's going to do this, and it's going to be my pi equals my pi plus, and then here again we're going to have a minus 1 raised to some value. And then it's going to be multiplied by, again, we have the 4 in the numerator on all those, so 4 divided by some value in the denominator. Okay, so now we need to calculate those. So again, the first time through we want the positive, and then a subtraction, positive, subtraction. So here again, we need to have an index variable this time. Let's use a different one. Let's use b this time, and we're going to set it equal to 1. Because this time we don't have MATLAB automatically updating that for us. So this is going to be, again, b plus 1. Last time it was I plus 1, but that'll give us 2 on the first time through, making that positive, 3 the next time, making it negative, so that'll give us our alternating plus or minus. So now down here, the first time through is 1, second time, so we have 1 is 1, 2 is 3, 3 is 5, 4 is 7, 5 is 9. So it looks like to me that that's going to be 2 times our index variable minus 1. First time through, 2 times 2 is 2, or 2 times 1 is 2, minus 1 is 1. Next time 2 times 2 minus 1 is 4, 5, 6. So that looks like a good equation to go with, minus 1. And we're going to suppress that output. And this time inside of our loop, because it's while loop, if we do not change our index value or the condition of the statement up here, it will stay in the loop forever and ever and ever, and you'll say, I can't get my machine to stop. If you do get into that situation, just remember Control C will end all calculations. Okay, oh, that's cool, we didn't report anything. I'm going to come up here and borrow this line right here and bring it down here, just for the interest of time. This is getting long. I'm already 43 minutes into this presentation, and it's not for my benefit but for yours. And then we just need to change this to B because we used B instead, but we still have my pi. Oh, look at that, and we got a whole bunch of iterations here, more than we need. We're going to go 7, 5. And this method took 1,000 iterations in order to get to this, where this method up here, again, if we change this back to where it's supposed to be, 0.001, it says 13 iterations. Oh, because I got too many zeros still. There we go, 6 iterations. I'm going to change this back so when I give it to you guys to look at, you'll not say, why did he do that? I say, okay, so, and then, there we go. So this method took 6 iterations. This method took 1,001, which kind of tells you which one's more accurate. Okay, problem number 7. Oops. Given the following system of linear equations, predict whether the system is linearly dependent using a determinant function. Okay, so let's create our A and B matrices. So this is going to be 2, 4, 5, and I like to put mine in so it looks like a matrix, just because that's the way I am. I'm kind of weird. Yeah, you are. So there's our A matrix. Our R matrix is going to be, and then this needs to be in vector or column vectors, so we're going to do semicolons after it. Let's do it like we're supposed to. 0. Oh, that's a -1. -1. Okay, so part A wants us to find the determinant of A. Is 0. Okay, and yeah, so if I mean, I may be stupid here, but it seems to me that if the determinant is 0, then there's no solution to the system of equations. And I do remember this, and I gave everybody full credit for this if they showed how to do it if it had been determined, and we will do that. So the left divide is, and I do this just in case it shows up on the exam. So x is going to equal a left divide r, not 4, 4, and then the matrix inverse is x equals inverse a times r. So again, you get these errors because a determinant of a is 0. So that was a poorly written problem if they wanted us to actually do the problem using those things. But I clearly indicate here the left divide is the left divide above the inner key, not the divide key that you normally use in mathematics. And then the inverse method is this way. There are other ways to solve systems of linear equations within MATLAB. However, if it says use left divide and use the matrix inverse, if you don't use those, then I don't give you full credit for them, even if your method works. I'm sorry I'm that way. Let's put in our final system break here. Okay, so this one here is a disk moves with rotational speed defined by a vector omega 0, 0, 20, and knowing that the point on the disk defined by the position vector of 2, 2, and 0. And find the total velocity of the point. Hint, the velocity is really the cross product of omega cross rp. So let's borrow this one and borrow this one, and I didn't ask you to run. Let's suppress that, make that a comment, suppress that, make that a comment, And then the velocity is equal to the cross product of omega and RP. And there's your answer, negative 40. That was an easy 10 points. So be ready for a cross product or dot product. Both of those could possibly be on there. Those come from chapter 10. And the last problem here, in a metric system, joules or kilojoules are used to measure energy, but the English system, BTUs are used. Conversion factor between each two units is 1 BTU equals a whole bunch of kilojoules. Define a vector BT joules from 0 to 100 in increments of 25. Okay, so BTUs is going to equal 0 by 25 to 100. And this wants us to use the table function in here. So table function works better with column vectors than it does with row vectors. So I'm going to surround this with parentheses and transposed it. Okay, and then calculate corresponding vectors, kilojoule values. So kilojoules is going to equal my BTUs times, somebody stole my time key, 1.0550663. Okay, results table following. Using the table function. Okay, so let's give it a little display telling the world what we're doing here. BTU converted to kilojoules, and then let's build the table. We do have, we do have. We need to have the clear here because up here I use table as a variable and that overrid it. So if we don't clear everything, the table won't work as a table function. So what are we going to put in our table? We're going to put our BTUs and we're going to put our kilojoules, and then variable names is going to be BTUs und kilojoules, and we need to have one of those funky things up here to make that work. And then we cross our fingers and hope it worked. And there's our table. BTUs and kilojoules. And there it is. That took almost an hour. I apologize for the length of it. I talk too much. Feel free to call me if you got any questions, comments, wants, needs, desires, concerns, or complaints. Hopefully there are no complaints, but there is always that possibility. Good luck, and we'll see you on the test.